What's up, guys? Today what we're going to do is we're going to do some exam questions on circles, more specifically arcs and sectors, because I feel like those exam questions, they do come up a lot and people do struggle with them. But in this video you should understand the hard questions on arcs and sectors, as well as questions with circles and other shapes, but you'll see what I mean in a second. So let's start with this one. This one we have a sector OAB, and we also have a semicircle OAC. We're told the angle here is alpha, and we're also told that the area of the sector is half of the area of the semicircle. So how are we going to find out what alpha is? Well, we know that the area is equal to alpha over 360 times pi r squared. But what is the area going to be? Well, we know that the area is going to be half of this. So let's work out what this area is. The area of the semicircle is just going to be a half, because it's a semicircle, times pi r squared. What's the radius of this semicircle? Well, if we know that this is the diameter, the radius is just going to equal 4. So therefore, it's going to be half pi times 4 squared, which is just equal to 8 pi. I'm going to leave it as 8 pi for now. Therefore, if this is 8 pi centimeters squared, then therefore the area of the sector is going to be a half of 8 pi, which is just going to be 4 pi, isn't it? Now, what we're going to do this time is we're going to substitute this in for our area. So 4 pi is equal to, we're trying to look for alpha over 360, times pi, times, and then we know that the radius is 8. So it's times 8 squared. And now we can solve this equation. I'm going to do this up here just so I can get some space. So we can first and foremost eliminate the pi's on each side, because that's just a lot easier. 8 squared is 64. So then 64 alpha over 360 is equal to 4. And therefore alpha is just going to be 4 divided by 64 over 360. And when we plug that into our calculators, we get an answer of 22.5 degrees. So now we worked out what alpha is equal to. Okay, cool. How are we going to find out what the perimeter of the figure is going to be? Well, the first thing we need to do is we need to work out what this arc is equal to. And we also need to work out what this arc is equal to. Let's start with the semicircle part, because it's just easier. C is going to equal 180 over 360 is a half, times 2 pi r, or pi times 8, either or. So it's going to be, again, 4 pi, isn't it? We sub in 4 for that, we get 8. We divide by 2. It's just going to be 4 pi. What about C for the sector? C is going to be 22.5 over 360 times 2 pi r. We know r is 8, so it's going to be 2 times 22.5 is 45, so we can say 45 over 360 times pi times 8. If we work that out, we get an answer of pi, just pi. So now, what we have is this length is equal to pi, this length is equal to 4 pi, so therefore the perimeter, P, is going to equal 4 pi plus 8. And so what we're left with is an answer of 5 pi plus 8, if you want to do it without a calculator. If you want to work that out with your calculator, we get an answer of 23.7 centimeters. What about something like this? For this one, we're told that this is a shape shown in figure 1. And it has OAB, which is a sector. We're told this is radius 6, so r is equal to 6. We're told the angle is 60 degrees. It was in radians before, but you guys don't need to know that for GCSE. We're told that the circle C has, well, it's inside the sector, and it has these two radiuses here, radii. So what is the area of the sector, and what's the radius of C going to be? Okay, so let's first work out the area. The area is simply going to be theta over 360 times pi times radius squared. So it's just going to be 60 over 360 times pi times 6 squared. And when we plug that into our calculators, we get an answer of 6 pi, which is also equal to 18.8 centimeters squared. Pretty easy stuff now that we've practiced it. How are we going to find the radius of circle C? Okay, so now this comes down to really understanding how the shape works. If this is a radius of the sector, it means this is also the radius of the sector. If we label this r, right, then this is r, and therefore this is 6 minus r, okay? And then this is r. So now what we can do is we can draw a separate triangle to represent this. This is going to be a right angle. I'll explain why in a later video, but when a circle has a radius that touches a tangent, it's going to be a right angle. But that's for the next video to explain. So let's draw the triangle. So this is R. This will be, we don't know what that is. And this is 6 minus R. Okay? So now, this is a right angle, and because this is the midpoint of the pendant, this is going to be 30. And so now what we can do is we can use SOHCAHTOA. Sine 30 is equal to opposite over hypotenuse. Yeah? And what did we say sine 30 was, if you remember correctly? Sine 30 is equal to a half. So now a half is equal to r over 6 minus r. And now let's make r the subject. So first thing we're going to do is times both sides by 6 minus r. So we're left with a half times 6 minus r is equal to r. We can times both sides by 2. So then we're left with 6 minus r is equal to 2r. And so we can put this r on the other side. So we're left with 3r is equal to 6. And therefore, r is equal to 2. So the radius of the circle is 2. So now we're told that this is the part that's going to be used for the pendant. How are we going to work out the area of this region? Well, if you can see, the area of the shaded region is just going to be the area of the circle minus the area inside. So let's work out the area of the circle. The area of the circle is going to be pi r squared, which is just pi times 2 squared, 4 pi. And so therefore, the area of, I'm going to try my best here, the shaded region, it's the best drawing I could get, it's just going to be 6 pi, which we had at the start, minus 4 pi, and so we're left with a area of 2 pi, which is how you would write it in a non-calculator paper. If you do not have a non-calculator paper, you can put it in decimal places, which is equal to 6.3 centimeters squared. What about something like this? So if you guys remember, this was a huge question back in the day, because we have a radius of 4 centimeters, and we're told to find area of shaded. Okay? Now, the first part, I'm fairly certain anyone with a brain could get. The area of the circle is just going to be pi r squared, which is equal to, what's 4 pi times radius squared? It's just going to be 16 pi, isn't it? Okay? Now, this is the part that people struggled with. As I mentioned earlier, if this is a radius, it means that this is a radius and that this also has to be a radius. And now look what we have here. This is a sector, right? So now we can work out what this sector is equal to. Because also they are center to center, this is a third of the circle, isn't it? So it's 120 degrees. So therefore, the area of the sector is just going to be 120 over 360 times pi times 4 squared, which is just going to be 16 over 3 pi. I'm going to leave it in terms of pi and then we'll do it in decimals at the end. Now, that doesn't help us with working out what one of these is equal to, does it? But notice what I did there. I drew a line, didn't I? Because this is a triangle. So now we can work out what the area of this triangle is. Because this is 4, right? This has to be 2 because it's halfway in between. It's a midpoint, isn't it? And therefore this is 60. So what we can do is we can say that the area of this triangle, I'm going to do it in a different color, is going to be a half AB sine C, which is the same as a half times 4 times 4 times sine 120. If you guys remember correctly, sine 120 is the same as sine 60, which is just root 3 over 2. So it's a half times (16) times root 3 over 2. And so we're left with an answer of 4 root 3, okay? Now, that means that the area of this segment, which is what we're after, because remember there are 4 segments, there's one here, there's one here, there's one here, and there's one here. What we're left with is, I'm not going to write in that color. I'm going to just show you. The area of that is just going to be the area of the sector minus the area of the triangle, which is just going to be 16 pi over 3 minus 4 root 3, okay? Which means that the area of those two is just going to be 4 times that. Okay? Which is just 64 over 3 pi minus 16 root 3. And so therefore, the total area of the shaded region is just going to be what we had before, 16 pi minus all of that, 64 over 3 pi minus 16 root 3, which is the same as 16 root 3 minus 16 over 3 pi. And if we want to put it in decimal places, now we can do it. Admittedly, we could have done it before, but I chose not to because I want you guys to get used to using exact numbers whenever you can. It just makes the calculations a lot easier. We get 11.0 centimeters squared. Thank you guys for watching. I hope this video made sense. If you guys liked it, please subscribe. It means the world to me and helps out the channel a lot. If you guys liked my videos and you want to see more, join my Discord server for updates, and if you have any questions you can ask me there. If you guys want to be tutored, drop me an email and you can get a meeting and a quote from me. Keep on learning, as you have no idea what you're capable of doing.